Hi all, welcome to Chandan Logics English YouTube channel. In this session, I am going to explain in detail units and measurement. First of all, I am going to explain you the topic, and then next, after the completion of topic explanation, I am going to display MCQs. So everybody from starting to ending, please all of you listen concentrating. Okay, please all of you concentrate on my session. It will be very helpful for your upcoming examination. As you all know that in every examination, like in units and measurements, from units and measurement chapter, you will get 1 or 2 questions for sure. Okay, so don't miss this session, students. It is very helpful for you. Is it okay now? Please make sure my audio and video are visible. Okay, visible and audible. Yes, so we will observe in each and every examination. So one MCQ will be definitely from units and measurements. So the question will be either tell me the SI unit of pressure or what is the SI unit of current. So likewise in every examination you will get one question from units and measurements for sure. And today we are going to learn in detail about these units and measurements. So from starting to ending, all of you listen properly so that you can attempt MCQs, which I am going to display in the end of the session. Okay, very good morning one and all, very good morning. So in detail we are going to discuss what is unit actually, what is measurement actually. So what are the types of units and measurements, and how many types of systems we have, how many types of unit systems we have, and what are the limitations of these units, okay, and what are the errors we appear. Okay, so these are all going to be discussed in this particular session. Okay, so first, what is measurement actually? So we all know. So I will explain you an example. So instead of reading the definition, if we learn through examples, it will be very understandable. So what is measurement actually? Measurement is nothing but it is a comparison process. For example, okay, one person is tall and one person is small. How can you say that? Okay, how can you say that? By measuring their heights. Okay, that is nothing but measurement is nothing but it is a comparison process. In simple, we can say measurement is nothing but numerical value into unit. Okay, in simple, measurement is nothing but numerical value into unit. For example, my height is 5.2 inches, 5.2 feet. That 5.2 is like a numerical value and this feet is units. That means what is this? Numerical value into unit is known as what? Measurement. It is also said as what? It is a comparison process. Okay, that is what we have to remember. What is measurement actually? So once again I am saying measurement is nothing but numerical value into. So remember this formula, numerical value into unit. Okay, numerical value means nothing but, so this is a rod, this is an iron rod. So how can we say that it is a iron rod? So how much length it is having? How can we find the length of this? By measuring. So the measuring of a particular object, either it may be a size or it may be an amount or may be a length. So that is established by what? By measuring, and that process is known as what? Measurement. Do you get what I said? Yes. Okay. So if you measure it with the scale, what you will get for 5 centimeters, and this 5 is the magnitude and this centimeter is the unit. The numerical value is nothing but what? We say it as what? Magnitude. Okay, the numerical value is considered as magnitude and the centimeter is considered as unit. Like what? The product of numerical value into unit, we say it as what? Measurement. For example, here measurement is equal to, for this 5 centimeter. This is the numerical value and this is the unit, and the whole thing is measurement. Okay, now unit. So this is what they have given in this definition. So what is this? The process of measurement is basically a comparison process. As I told just now, okay, a person is taller than me and I am shorter than him. How can you say that? By measuring my height and that person height. That is nothing but this measurement is a comparison process. In simple, measurement is equal to numerical value into units. And what is unit actually? Units are nothing but the fundamental physical quantities, not fundamental. Units are the fundamental physical quantities which are set standards. Okay? The unit of a physical quantity is an arbitral chosen standard which is widely accepted by the society. That means the units we choose are standard, already designed. The units which are we using, they are standard values which are already accepted by the society. Okay, that is the difference between measurement and unit. Clear all of you? Hi. Next. And next one is standard. Okay, as I told you, okay, what is standard actually? The actual physical quantity embodiment of a unit of a physical quantity is known as standard. As I told just now, the units which are set as standards. So, in order to measure something, that particular, okay, if it is a length, it has a certain unit value. If it is a circle, in order to measure that, we need to know its diameter. So, that diameter consists of one certain value, one certain unit. So, those are set standard. Those are the standard values set up by the scientists, and those are accepted by even the society also. Okay. For example, I have told just now. So, measurement is equal to numerical value into unit, as I told just now. For example, length of a rod is equal to 8 centimeters, means where 8 is the numerical value and m is the unit. These numerical value is known as what? Magnitude. Okay. Next. So, fundamental. So, how many types of physical quantities or units we have? So, this is very important. I think everybody have knowledge regarding this. Okay. Generally, we have two types of units. Fundamental units, derived units. What are these fundamental units? These fundamental units are not derived from any other fundamental units. They are set primarily. Okay, these fundamental units are they are not derived from any other fundamental units. So, what is this derived units? So, these derived units are these derived units are derived from the both fundamental units. Two or more fundamental units gives us what? Derived units. That is the difference of fundamental unit and derived unit. You all know about this. Okay. So, what are the examples of fundamental units? Like mass, length and time. Okay. This mass, length and time, these are the fundamental physical quantities. Okay. What are the fundamental physical quantities which are not derived from any other fundamental quantities are set as what? Fundamental physical quantities. What are those? Mass, length and time. And what are the fundamental units? What are the fundamental units of these fundamental physical quantities? Length, kilogram, meter and second. So, mass unit is kg and length unit is meters and time unit is seconds. These are fundamental. These units are not derived from any other units. For this purpose, these are known as what? Fundamental physical units or physical quantities. So, in the same way, what are derived physical quantities or derived units? So, these derived physical quantities or derived units, so they are derived from one or two combined fundamental physical quantities or units. For example, what are the derived physical quantities? Like velocity, density and force. These are the derived fundamental physical quantities. Okay. So, what is the formula of velocity actually? Distance by time. Time is distance by time. And similarly, what is the what is the formula for density? Mass by value. And in the same way, what is the unit of force? Force is nothing but what? Like length by area. Sorry, mass by area. Okay, mass by area is the. So, what is the distance? Distance is measured in length and time is measured in L by S. That is nothing but what? Velocity. Velocity is a desired unit. Velocity is a desired physical quantity and its unit is meters per second. So, length is measured in how many? Meters per second. Okay. Similarly, mass is measured in kgs, and volume, this is what? Mass by volume. Volume is measured in meter square. And in the same way, okay, this is what? Force. Force is nothing but what? Length by volume. Okay, so length, mass by volume. Mass is nothing but kg and meter per square, or else F is equal to ma. F is equal to ma, right? So F is equal to kg. And what is acceleration? Acceleration is nothing but the rate of change of velocity. What do you mean by rate of change of velocity? That means d by t square. That is nothing but what? M meter square. So these are the derived units. Okay? Next. Am I audible and visible? Please, any one of you confirm. Am I audible and visible? Any one of you confirm, am I audible and visible? Okay, done. Next, I have said what are the systems of units. Okay, so in general, we have like 4 types of unit system: CGS, MKS, FPS. But as of now, many like countries accept SI units for each and every physical quantities. Many countries accept SI SI units only. Okay, so what is CGS system actually? C means centimeter, G means gram, and S means second. Centimeter is the unit for length, and gram is the unit for mass, and second is the unit for time. And similarly, what is FPS system? Okay, foot, pound, and second. So these are to express, foot is the measurement for length, pound is the measurement for mass, and second is the unit for time. And in the same way, MKS system. In MKS system, meter, kilogram, and second. Okay, these are used to express length, mass, and time. But as of now, many countries accept SI units only. So what are the SI units actually? Length, mass, time, electric current. So length is the unit for what? What is the unit of length? Meter. What is the unit of mass? kg. What is the unit of time? Second. What is the unit of electric current? Amperes. What is the unit of thermodynamic temperature? Kelvin. What is the unit of amount of substances? Mole. And what is the unit of luminous intensity? Candela. So these are the units which are accepted throughout the world. Okay, so as we have many types of systems, but SI units are accepted throughout the world. Okay, they are the standard. So in each and every examination, we can see what is the unit of pressure, or what is the unit of luminous candela, and what is the unit of electric current. Okay, so we have to learn all the types of units, and what are the fundamental units and what are the derived units. And even we have to know what is dimensional formula and of each and every physical quantities. Okay, so next. So these are the semi SI base units, quantities and units. Very, very important, students. Make a screenshot of it. I have gathered this information. I have gathered a lot of information of regarding all the units. Okay. So length, what is the unit of length? Meter, and the symbol is M, as you all know. And what is the unit of mass? kg, kilogram. What is the unit of time? Second. What is the unit of electric current? Ampere. What is the unit of temperature? Kelvin. What is the unit of amount of substance? Mole. What is the unit of luminous intensity? Candela. So one thing is that these are all fundamental physical quantities. That means they are not derived from any other physical quantities. Okay, luminous intensity, it is also a fundamental physical quantity, and the unit of that luminous intensity is candela. Very, very important. Okay, from this set you can expect one question for sure. Okay, what is the unit of luminous intensity, or what is the unit of electric ampere, electric current. Okay, so very, very important, students. Make a screenshot, or you can note it down in your notebook. And next, Christmas offers are going on. Each and every students utilize these wonderful opportunities. And special offers are also going on. You can get any course at just 399 rupees. 0 to Hero course is also available on our Chandan Logics app. Christmas and New Year offers are also going on. SSC GD special batch complete course is also available on our Chandan Logics app. SSC exam complete course is also available. Like a railway exam is also available on our Chandan Logics app. Bank exams complete course is also available on our Chandan Logics app. Bank SSC RRB combo course is also available. APPSC, TGPSC, SI Constable courses are also available. Next, so those are the like general basic, very important. So radian is the unit for angle and steradian is the unit for solid angle. Okay, radian is the unit for angle and steradian is the unit for solid angle. For example, okay, very important students. Am I audible and visible? Please, any one of you confirm. Please, any one of you confirm, am I audible and visible? Okay, done. Okay, so what are the two supplementary units? Radian and steradian. Okay, so radian is nothing but, what is this? It is the unit of plane angle. For example, this is a plane. Okay, we have, this is an circle. Okay, and this is the center of the circle. We have to find the angle between the this ray and to the this. Okay, we have to find the angle of this plane, angle of the, we have to find the unit of this like a plane angle. So how we can find it? Okay, so what is the unit of this plane angle? And the unit of this plane angle is nothing but what? Radian. In the similar way, actually this is the 2D figure. If it is a sphere, that means if it is a ball, and how can we find this? Okay, so think this as a sphere. Okay, how can we find the angle of this solid angle? And the unit of this solid angle is nothing but what? Like dA by r square. That is nothing but what? It is steradian. Very important. For a solid angle, for a solid plane, in order to find its unit, the unit of the solid angle is steradian and the unit of the plane angle is radian. Very important, students. And these two units are considered as what? Supplementary units. Okay, done. Next, advantages of SI units. So what are the advantages? We have many units like CGS units, FPS units, MKS units, SI units. But why only the SI units are accepted throughout the world? What are the advantages of these SI units? We have to know. Okay, so what? It is internationally accepted. These SI units are internationally accepted and it is a rational unit system. Okay, it is a like a debatable unit system. It is a rational. That means we can have the rational values also. In this type of SI units, there appears rational values also. And it is a coherent unit system. Okay, it is a coherent unit system and it is a metric system. It is closely related to CGS and MKS system of units. So it also uses decimals also. So why it is what are the advantages of SI units? It also uses decimal values. Okay, it also uses rational values. It also uses metric values. Okay, and it is accepted internationally. For this purpose, most of the scientists or most of the countries use this SI units for any measurements. Okay, next. Next, Other important units of length. Okay. For a smaller object, in order to measure the unit of this digital pen, I can measure it with the help of scale. Okay. For example, I want to measure the distance between the earth and the sun. Can we use the unit like meter? Can we use the unit meter? No. So in that particular cases, we have different types of length units. Okay. Even we have different type of length units. So what are those? We will discuss now. Okay. For a smaller distance, we can use the unit meter. If the distance is more, can we use the unit meter? No. So what are the units in those particular cases? Now we are going to discuss. Okay. So other important units of length. For measuring large distance, example distance of planet and stars, etc. If you want to measure the distance from our earth to the sun, we cannot measure it by using a length or like meters. So there appears some units. So what are those units? For example, the average separation between the earth and the sun is called 1 astronomical unit. So what is the unit? Okay, what is the unit of length to measure the distance from the earth and the sun, and that unit is known as what? It is not meter, it is astronomical unit. Very, very important. Okay, the distance, what is the measurement, what is the unit to measure the distance from the earth and the sun, and that unit is known as what? 1 astronomical unit. Okay, 1 astronomical unit is equal to 1.496 into 10 power 11. 1.4962 into 10 power 11 meters. Okay. Now we are converting the astronomical units into meters. Did you get what I said? Okay. So 1 astronomical unit is nothing but it is the distance between the earth and the sun, and 1 astronomical unit, if we want it into convert it into meters, so 1 astronomical unit is equal to 1.496 into 10 power 11 meters. Very, very important. Okay. And in the similar way, the distance travelled by the light in vacuum in 1 year is called light year. Okay. Even the distance travelled for the light to travel in vacuum in 1 year is known as what? Light year. So light year, it is also the unit of length. It is also another form of unit of length. Okay. So 1 light year is equal to 9.46 into 10 power 15 meters. So if we want to convert the light years into meters, 1 light year is equal to 9.46 into 10 power 15 meters. This is also a standard value and it is very, very important. Okay. 1 astronomical unit is equal to 1.496 into 10 power 11 meters. 1 light year is equal to 9.46 into 10 power 15 meters. Very, very important, students. These are standard values and you must remember it for sure. And next thing, the distance at which arc of length of 1 astronomical unit subtends an angle. Okay, so we are at this position. So I am on earth. So if I want to measure an arc distance from earth to an arc distance from earth to sun. So in this manner, it is 1 astronomical unit. If I want to find the angle between the earth and sun, like arc angle between earth and sun, and in that particular cases, the unit will be 1 parsec. Okay, 1 parsec is equal to 3.08 into 10 power 16 meters. Very, very important. Okay. So these 3 standard values are very, very important. These are the another forms of units of length. Okay. For a smaller distance, we will use meter as length. For a larger distance, we have different units for different things. Okay. Yes. Next. Dimensions. So here comes the dimension. For example, the dimensions of a physical quantities are the powers to which the fundamental units of mass, length and time must be raised to represent the given physical quantities. Dimensions are nothing but, so mass, how you will denote this mass as m. Okay. in the similar way, how you will denote length as L? How you will denote electrical current? Electrical current we denote as what? I. In the similar way, temperature is denoted by K. These are the dimensional formulas. Okay. If for the mass, we will denote it as M. For length, we will denote it as L. And these are considered as what? Dimensional formulas of physical quantities. Okay. Next. Applications. Application of physical quantities. For example, okay, you know what is force. Force is nothing but what? Like MA. Okay. So M is nothing but what? Mass. And A is nothing but what? Acceleration. And what are the formulas? Mass we can write. In dimensional formula, mass is denoted by M. And what is the dimension for this? 1. So this is known as dimension and this is known as dimensional formula. Okay. And in the similar way, so what is the formula for acceleration? Acceleration formula is velocity by t square. Okay. The rate of change of velocity is known as what? Acceleration, right? So what is velocity actually? Like a speed by time. So for in this purpose, I will write like this. So what is velocity? Okay, velocity is measured in meters and time is measured in s square. Okay, so in this this purpose we will write as like m square, next length L and s minus 2. So this is the formula for the force. So this is the dimensional formula. Okay, next. And these are the dimensions. The power which we write on the dimension formula, we will denote it as dimension. Next. So limitations. Okay, what are the limitations of dimension? This is very, very important. These dimensions are limited to dimensionless constants. Dimensionless constants cannot be calculated. For example, coefficient of friction. Coefficient of friction. The ratio of friction values is known as what? Coefficient of friction. This is a non-dimensional value. That means these do not have any units. So these dimensions are limited to this dimensionless quantities. Okay, coefficient of friction, this coefficient of restitution. Okay, these do not have. And even like strain. Okay, what do you mean by strain? Length, change in length to its original length. Length by length. Okay, change in length to its original length is known as what? Strain. For this strain, there is no dimension. So I will explain you in clear. So strain, what do you mean by strain? Means, for example, this is an rubber band. Okay, so if we apply force, that means if we stretch it, so what happens? The length will extend. The length will be extended. So now what is the strain? Strain is nothing but the change in length. Change in length to its original length. So initially how much it is? Original length. It is also measured. The length is measured in meters and even the original length is also measured in meters. Meter cancel. That means strain is a dimensionless values. In this purpose, the dimensions are limited to dimensionless values. Example, strain. And in the similar way, so these dimensions are not applicable to trigonometric, exponential and logarithmic terms. Okay, in order to analyze trigonometric, exponential and logarithmic terms, these dimensions cannot analyze. Okay, and in the similar way, these dimensions can equalize the powers of M, L and T. Okay, these dimensions can equalize the powers of M, L and T, but these they cannot analyze exponential equations, logarithmic equations and trigonometric equations. Can you ever find, did you ever find the dimensions for trigonometric equations, exponential equations and logarithmic equations? No. Why? Because they are limited. Okay, they are not used in these equations. So finally, now these are very important. The rules for determining the number of significant figures. Okay, now we are going to learn about the rules of the significant figures. I will explain you one by one in detail with example. Okay, first one is all non-zero digits are significant. All non-zero digits are significant means, for example, 105.04. So this is a numeric value. Okay, this is a numeric value. So in this particular numeric value, how many significant digits we have means 1, 2, 3, 4, 5. So this is the rule. And second one is all zeros between non-zero digits are significant. All zeros between non-zero digits are significant means 2008. Okay, these are the two zeros which are between two non-zero digits. So how many significant digits we have? 4. And third, all zeros to the right of the last non-zero digit. All zeros to the right of the last non-zero digits. For example, 1000. So this is what they have given. In these cases, number of significant digits will be only 1. Okay, they are not significant. They are to the right of the non-zero digit. So these are the sum of the rules of the significant digits. Okay, you must remember it. Next. So these are the sum of the units and which we use in general. Okay, so what is the unit of minute? How we will write it as minute. And what is the unit? Second. And in the similar way, hour is denoted as H and 1 hour is equal to 60 minutes. So these are the standard values. I think everybody know this. And day is denoted as D and 1 day is equal to 24 hours. And 1 year is equal to, we will denote it as Y. And degree we will denote it as small circle. And liter we will denote it as L. Ton we will denote it as T. So 1 ton is equal to 10 power 3 kgs. And carat we will, carat means that is not like eating carrot, gold carats. Okay, the measurement of gold is measured in carats, right? So 1 carat is, we will denote it as C. So 1 carat is equal to 10 power 3 mg. In the similar way, bar. The unit of pressure is bar. So bar is denoted as bar. Curie, like wrong ton, quintal, barn, array, hectare, standard atmospheric pressure. So these are all the general terms which we use in our daily life. Okay, atmospheric pressure, standard atmospheric pressure, we will denote it as ATM. Okay, hectare, how you will denote this hectare as HA. 1 hectare is equal to 10 power 4 meter square. 1 hectare is equal to 10 power 4 meter square. These are all the like general values which we will use in our daily life. So do you know what is the real observable units? Our observable universe is at a distance of 10 power 55. This is also very, very important. Make a screenshot of it, table students. Our universe, observable universe is at a distance of 10 power 55. And in the similar way, our Milky Way galaxy is at a distance of 10 power 41. And our sun is at a distance of 10 power 30. And our moon is at a distance of 10 power 23. Very, very important. Okay. From the earth, our moon is at a distance of 10 power 23. Our universe is, observable universe is at a distance of 10 power 55. So these are all the dimensions, units of things which we use in our daily life. Okay. And size of a proton. How the size of a proton will be measured? The size of a proton will be measured in units. So in order to not to miss each and every question, okay, so you should not miss a single mark from this chapter. So that's why I am stressing in detail. Okay, in each and everything I am going to explain in detail. Why? Because you should not miss a single mark from this chapter. Okay, for this purpose I have given all the tables which are helpful for your examinations. Size of a proton. How the size of a proton? It is 10 power minus 15. In the similar way, make a screenshot of it, these students. Distance of moon from the earth will be 10 power 8 in length. Distance of Pluto from the sun is 10 power 13. Size of our galaxy will be 10 power 21. So these are the standard values. Okay. So make a screenshot of it, students. Okay. Next. So make a screenshot of it, this also. Okay, electron's mass will be, okay, the mass of the electron will be 10 power minus 30. and the mass of the proton will be 10 power minus 27. Very, very important. Okay, this all comes under this units and measurement chapter only. Mass of a proton will be 10 power minus 27. Mass of the electron will be 10 power minus 30. And uranium atom will be 10 power minus 25. Red blood cell mass will be 10 power minus 13. What is the mass of red blood cell which is present in our human body? 10 power minus 13. And what is the mass of the dust particle? It is just 10 power minus 9. Okay, 10 power minus 9 means what? 1 by 10 power 9. That means it is invisible. Next. So, range and order of time intervals. So, this is important things. Wink of a eye. Okay. So, in order to wink our eye, how much time it is taking? It is taking 1 by 10th second. Okay. So, 1 second, right? So, the wink of a eye, it takes just only 1/10 of the second. Very, very important. Okay. How much time the wink of an eye takes? 1 by 10th of the second. Okay. And rotation period of the earth takes 10 power 5. How much time the rotation of the earth takes? 10 power 5. That means 10,000, like 1 lakh. Okay, 1 lakh second it takes. Okay, the wink of an eye takes 1 by 10th time of 1 second. In the similar way, rotation of earth takes 1 lakh seconds. The single rotation of earth takes 1 lakh seconds time. In the similar way, average human lifespan 10 power 9 and like age of the universe is 10 power 17. Okay, 10 power 17 age of the universe. So, these are all some of the important things to be noted. Okay, next. Area. So, these are all the dimensional formulas of some physical quantities, as I told you already. Okay, dimensional formulas, nothing but mass is denoted by capital M, length is denoted by capital L, and the value which is at the power of that particular physical quantities are considered as dimensions. For example, okay, so area, what is area? Area is nothing but what? How can we write as A square? A is nothing but what? Length square. Okay, so what is the dimension, physical quantity area, and its dimensional formula is L square. So in this L square, what is the dimension here? 2. That is the difference between dimensional formula and dimension. And next comes volume. Volume is nothing but L square. And similar way, density. So what is the formula for density? Mass by volume. Okay. So now what is the unit for mass? Kg. Okay. What is the unit for mass? Kg. And what is the unit for length? Length is nothing but what? Volume L cube. So mass is nothing but what? M L cube. L minus 2. So here we have to find. Okay. This is the way how to find dimensional formula. Okay. And similar way, force. So what is force actually? Force is nothing but mass into acceleration. So how can we measure mass? Mass will be measured in like kgs. Kg is nothing but what? M. Okay, mass we will denote it as M. And acceleration, how we will write this acceleration as velocity by time. Okay, velocity we will measure velocity by t. Okay, m L by t square, that is equal to m L t power minus 2. So in the same way we will find each and every physical quantities dimensional formulas. Okay, next. So this is very, very important, students. You will get one from this. Okay, temperature. What is the dimensional formula for temperature? K. That's it. Okay. So if you want anything, mention it in the comment section. I will explain. So electric charge. What is the dimensional formula for this electric charge? Just Q. Okay. Make a screenshot of it, students. Very, very important. Next. So first question. So everybody, so till now the explanation of units and measurements are completed, and now I am going with MCQs. First question, measurement of a physical quantity fundamentally involves estimation without reference, comparison with a standard unit, counting objects directly, mathematical calculation only. Each and every student mention your answers in the comment section. Yes. So till now explanation of units and measurements chapter is completed, and now I am going to with MCQs. Come on students, what is the answer for this question? As I told you already, okay, what is measurement? Measurement is nothing but it is a comparison process. One person weight is like 50 kgs and another person weight is 40 kgs. The numerical value is considered as magnitude, and the kg value is, kg is considered as unit. Numerical value into unit is known as what? Measurement. That means it is a comparison process in general. Yes, very good. And the answer for this question is option 2. And in general we can write as measurement is equal to numerical value into unit. Okay, next. The numerical value obtained after comparing a physical quantity with its unit is called unit standard magnitude dimension. So as I told you, okay, a person's height, I am comparing the person's height with another person. Okay, I will get a value, and that particular value is known as what? It is a dimension or a magnitude or a unit. So tell me students, very good. What is the answer for this question? For example, so this is the length. Okay, length of the rod is equal to 8 meters. After measurement, I have got the length of the rod as 8 meters. So what this 8 is considered as? What this unit is considered as? So tell me students. No. This numerical value is considered as what? And this meter is considered as unit. I have told you already. This numerical value is considered as what? That numerical value is considered as magnitude. I have told in the beginning of the session only. Okay. When we are comparing, in a comparison process, after measuring, we will get certain numerical value. Okay. And that certain numerical value is known as what? Magnitude. Very, very important. Okay. Next. Which of the following correctly represents a measurement? Unit into standard, magnitude into dimension, numerical value into unit, dimension into unit. What is the formula for measurement? So tell me students, what is the answer for this question? Everybody who are in the live session, please mention your answer in the comment section. And also, who will see this live session after the completion of the live? So mention your answers in the comment section, and see this session once, twice, thrice, so it will be very interesting. Okay. So what is the answer for this question students? Very good. So measurement is equal to numerical value into unit. Very good. Next. Which of the following is a fundamental physical quantity in the MKS system? Velocity, force, mass, density. So I have told you in the beginning of the session itself, what is fundamental physical quantity, what is derived physical quantities. What are fundamental physical quantities? If the physical quantities which are not derived from any other physical quantities, we say it as what? Fundamental physical quantities. If we derive from one or two fundamental physical quantities, we say them as what? Derived quantities. So tell me students, in the given option, which is considered as the fundamental physical quantity? That means that quantity is does not derive from any other physical quantities. For example, velocity. Okay, velocity. What is the formula for velocity? Distance by time. That means it is having two or more fundamental units. This is not a fundamental unit. In the similar way, force. F is mass into acceleration. It is also having two or more fundamental units. So this is not the fundamental units. So mass. So mass, are we deriving this mass from any other physical quantity? No. So mass unit is kg, and the answer for this question is option 3. Okay. Next. And density. How can we define density as? Density is equal to mass by volume. It is also having two fundamental physical quantities. So it is not a fundamental physical quantities. This velocity, force and density, these three are derived physical quantities. Clear? Next. The unit kg meter per second square represent which derived physical quantity? Energy, pressure, force, power. So tell me students, okay, so force, for example we will see force is equal to m into a. So how can, what is the unit of mass? Unit of mass is kg. So what is acceleration? Acceleration is nothing but what students? Acceleration is nothing but velocity by time. Okay, now velocity is nothing but what? Velocity is nothing but distance by time. Okay, distance by time, and here time will be again. So what can we do now? Kg, like distance. How can we measure the distance? Distance is measured in meters. In the similar way, t square, and the time is measured in seconds. Okay, meter. So what is the answer for this question? Yes, force. So here how to find the dimensional formulas if any physical quantity is given. Okay, for this purpose you have to know what are the fundamental physical quantities units. If we know the basic fundamental physical quantity units, you can, and if you know the formula for a particular physical quantity, you can easily derive any type of dimensional formulas or dimensions of each and every physical quantity. Okay, next. Which of the following is not a base quantity in the SI system? Electric current, luminous intensity, angle, amount of substance. As I have told you already, there exist two types of units: basic standard units and supplementary units. Okay, so what are the basic standard units? I have told you already: length, mass, ampere. Okay, and like length, mass, electric current, luminous candela, amount of mass. Okay, these are all considered as what? Basic standard units. And when it comes to supplementary units, what are those supplementary units? Angle, okay, radian and steradian. So tell me students, what is the answer for this question? In the given question, which are not the basic quantity? Okay, so nobody is giving answers to my question, and the answer for this question is angle. Okay, as I told you already, this radian and steradian, these both are considered as supplementary units. These both are considered as what? Supplementary units, but they are not the derived units. And when it comes to this electric current, what is the unit of this electric current? Ampere. And what is the unit of this luminous intensity? Candela. What is the unit of amount of mass? Mole. So what is the unit of plane angle? Here have plane angle, solid angle. Plane angle is radian and solid angle is steradian. Okay? Yes. Next. 1 light year is defined as distance between Earth and Sun, distance travelled by light in 1 year in vacuum, radius of Earth's orbit, distance subtended by 1 arc second. So tell me students, we have discussed. So not only for a smaller distance we can use, for the length we can use the unit as meter. For a larger distance, for example, distance between Earth and Sun, how can we measure? Okay, the distance between Earth and Sun can be measured by a unit called astronomical unit. And in the similar way, how can we measure the distance of light year in a vacuum? Like 1 light year. So what is the answer? Distance travelled by light in 1 year. And this is known as what? 1 astronomical units, and this is known as what? 1 parsec. Okay. The dimensional formula for velocity is, so tell me, so what is the formula for velocity students? Velocity is equal to distance by time. Okay. What is the unit of distance actually? Unit of distance is length. Okay, unit of distance is nothing but what? Length. And what is the unit of time? How can we, dimensional formula is nothing but distance is denoted as, okay, distance is nothing but what? L. And time is written as in second S. How can we write this? Okay, L by S. So L S power 1. S is nothing but what? Time. T power minus 1. So option 2 is the correct answer. Okay. Next. According to the principle of homogeneity of dimension, only vectors can be added, dimension constants can be evaluated, dimensions on both sides of an equation must be same, scalars and vectors are distinguishable. So homogeneity means what? Homogeneity means what? So tell me students, hi students, hi. What do you mean by homogeneity? Homogeneity means what? Dimensional constants can be evaluated or dimensions on both sides of an equation must be same. So what is the answer for this question students? Yes, and the answer for this question means the dimensions on both sides of the equations must be same. For example, F is equal to MA. So if we find the dimensional formula for this, the dimensions is nothing but what? The power of the given dimension formula. Okay, that power is known as what? Dimension. Those must be same on both sides of the equation. That property is known as what? Homogeneity. Okay. Which of the following is the limitation of dimensional analysis? It can convert units, it checks correctness of equation, it determines numerical constants, it cannot analyze trigonometric equations. As I told you already, what are the rules? So what are the limitations of dimensional analysis? It can check the equations. It can check the equation. Okay, it is not applicable for, this dimensional analysis is not applicable for trigonometric equations, logarithmic equations and exponential equations. But we can equate, if the powers are in the form of ML, so we can equate the equation. So what is the answer for this question students? Very good, it cannot analyze trigonometric equations. Special offers are going on. You can get each and every course at just 399 rupees. Zero to Hero course is also available on our Chandan Logics app. Christmas and New Year offers are also going on. SSC GD complete course is also available on our Chandan Logics app. SSC exam complete courses are also available. Bank exams are also available. Railway exams are also available on offers. Bank, SSC, RRB combo courses are also available. APPSC, TGPSC, SI Constable courses are also on offers. APPSC, TGPSC Group 2 courses are also available on offers. APPSC, TGPSC Special Batch courses are also on offers. UPSC, CSAT courses are also offers. And single subject courses are also on offers. Okay, that's all for today. Let's meet in the evening session with Jainism. Okay, bye students, take care.